Let's talk about PA design. In my opinion, it's very important that a front of house engineer has a big knowledge about designing PAs, because that is your tool. On the one hand, your tool is the microphone. On the other hand, it is the PA. Whether you have a system engineer or not, but even to talk with your system engineer, not just only to give a mix and that's it. You always have to keep in mind that you're doing the sound not for your position. You're doing it for the audience. First, let's think about the summation of the loudspeakers. So, normal PA situation, you have a system on the left and you have a system on the right, and they perfectly sum up in the middle. So, especially the low frequencies sum up on a wide area in the middle. That gives you an issue not to sit in the middle. Why not to sit in the middle? In the middle you have the best mix. No, in the middle of the audience, in the perfect summation area of the audience, only a handful of people are sitting there compared to the amount of people sitting on the left and right side. So that's why I make the decision to move just 1-2 meters outside the middle and place my front of house there, because I get a much more precise average about that what the people or the most of the people are listening to. If I would sit in the middle and I enjoy the heavy sub-lows I have there, I can be sure that the people left and right from me will have less sub-lows. You're doing the job for the people. That's why just slide out of the middle just a little bit, and this will give you much more the feeling of that what the people are listening on the left and the right. The PA design. We don't have to talk about left, right, line array or the outhang. So I think that's normal stuff. So we don't have to talk about that you need an outfill, you need a main hang. But let's have a closer look at the main hang. Where should it be placed? A couple of years ago, I got a job offer and they came along with, are you brave enough to place a PA system 3 meters upstage? So more or less behind the first players of the orchestra. And what do you think about that? Placing a PA next to, or left and right to 80 condenser microphones. I said, yes, let's do that. I can agree with that. And I have only one thing what we have to do. To be able to make this challenge happen is to make the line array long enough. I need a line array of approximately 8 meters. An array which is 8 meters long is about the wavelength of 50 hertz. 50 hertz has a wavelength of 6.8 meters, and as soon as the array is longer than the lowest frequency I want to transmit, I get a directivity in this frequency. Indeed, that really works out. A lot of loudspeakers, 8 meters is something like, for example, 12K1 plus 8K2 from L-Acoustics. So it's a huge setup. But a lot of loudspeakers, they do a job silent as well, or on a low level. Even when you drive a PA system not on the edge of what is capable to do, you have much less distortions and you have a much better directivity on all frequencies. So let's have a look at the other side. What is if I have a line array which is pretty short? Of course, there are some shows not as big, and it's not possible to suspend so many loudspeakers. But let's say if I have a single loudspeaker or just a small line array, the low frequencies and the low mid frequencies will depart from the line array with an omnidirectional direction. So no directivity at all. And of course, this bounces back to the stage, and that will make you trouble with bleeding sound of the PA or with feedbacks at the last stage when you need the loudness and the level from the PA. Make a line array as long as possible. Has the advantage of giving all frequencies directivity. But that's not everything. As well, it's about the height of a line array. So there are shows, for example television shows, where your line array has to go straight up. So in a normal arena, when you have maybe the button loudspeakers at a height of 10 meters or 12 meters, even a long line array, so what is the result? In most of the arenas, you have an LED wall going all the way through the whole arena. You face, from the view of the loudspeakers, from the array, the LED wall with a downwards angle. And this downwards angle reflects the sound back to the stage, so you get a huge slapback. Another disadvantage is you're sitting more or less in the front, and so you see the optical wise the stage there, but you listen to it somewhere from up there. That means the acoustical world does not fit the optical world. So, and if you lower the line array, let's say most of the times I'm at a lowest edge of 7 meters in arenas, you bring these worlds much more together. As well, when you are very high, the angles in your line array, they have to be pretty high, so that in your line array makes a very strong curve at the end. What happens? In the high frequencies, you can calculate the line array loudspeaker by loudspeaker, but not in the low frequencies. In the low frequencies, the line array is like one single loudspeaker. And as soon as you have a very strong curve in the line array, your low end will get an angle downwards. So with an angle downwards for the low frequencies, you have at the end of the floor, you will have a very strong impact of low frequencies. But when you're sitting on the second balcony, you will hardly have any low or mid-low frequencies. And as well, in the first row, hardly anything. So you mess up the equality of the whole array. It's much easier if you lower the array and then you spread the array upwards and downwards, and you give the low frequencies a directivity more or less in 0 degrees. Then you cover the whole venue with that. What I don't like as well, when you angle the line arrays that way, that the main speakers already hit the very first row of people. Why? Therefore you have near fills, out fills, or something on the floor or on the edge of the stage. With speakers from the line array hitting the first row, you immediately have the effect that you separate the acoustical world from the optical world. And that's just simply, that's not nice. And there's no need to make these use huge angles with the side effect of giving a huge distortion to the low frequencies. So let the line array have the first impact, maybe 8th, 9th, 10th row, and let the first few rows be done by speakers on this edge of the stage. It's a much better solution. It's so easy to get the acoustical view together with the optical view. And the more you are far away from the stage, it equals out, and then the line array can overtake the role of the speakers at the edge. Concerning the position of the line arrays, it sounds very strange that it is possible with so many microphones on stage and a PA system which is pretty low, so 7 meter lowest point, to move it upstage. So that means to the rear of the stage. But it is logical. So if you look at the low frequencies, how they behave in line arrays. So when I have an 8 meters array, so I have a directivity on 50 Hertz, but how are my 50 Hertz going? They're going, of course, into there's the front of the stage. They go a little bit down. And the same they do on the back side, of course. So when I have the line array at the front of the stage, that what the array is doing on the rear will hit the stage in a certain point. Now, when I move the array 6 meters, 7 meters, 8 meters, something, upstage, the hole for 50 Hertz, which I have below, exact below the line array, will move with the line array. And the instruments which I have on the rear on the stage, they will be less affected by these low frequencies coming from the main array. It sounds strange, but moving the line array a little bit upstage makes your stage even more quiet. It's hard to imagine that, but it is like that. And on the other way around, the sub-lows are in front of the stage. So I cover more of the audience with sub-lows. So sometimes it's a better decision to have a long array and just move it upstage. Sounds strange, but that's the way it is. Okay, let's talk about subs. With subs, of course, if you want to have a powerful sub, place it on the ground, use the ground effect, having an end-fired array or a bass line. So there are a couple of possibilities. But if we think about classical music, stacked subs is not the best solution. Why? As I told before, in symphonic music, I don't need near fills in the front because the audience is listening to the unamplified orchestra the best way. It sounds much better than when it comes out of loudspeakers. But as soon as I place some subs directly in front of the people, they will have a distortion about concerning that what they are listening to. And so I think it's very easy to understand that placing subs for an unamplified area, placing subs directly in front of the people is not the best solution. So what can we do? Yeah, fly them directly behind the line array. That's a typical situation. You can make this flown bass. You can make these flown sub array. It can be a cardioid array, or even one of the nicest solutions I know is a mono and fired array in the middle of the stage. What is a mono and fired array above the stage? You have 4 subs behind each other. From behind, the first, the second one delayed to the first, the third to the first, and the fourth as well delayed to the first sub loudspeaker. So regular and fired system. Why do I like it? I know as soon as it is in the middle of the stage, I mess up the frequencies, the crossover frequencies from the sub-array to the main loudspeakers. But what is the big advantage? The end-fire characteristics in maybe 12, 13 or 15 meters height, they point out on their 0 degree line. For the first rows, they have much less level compared to the 0 degrees. But in the 0 degree direction, the audience are sitting 60, 70, 80, 90, 100 meters away. So that equals out in level. And another very big advantage, we are talking about low frequencies. Low frequencies have long wavelength, and these long wavelengths cancel out or sum up everywhere in the whole venue when I have a left and right system. So I have interferences everywhere in the whole venue. So I have points where some frequencies can be heard very loud, and in some points these frequencies totally cancel out. As soon as I have only a single sub-array, a mono sub-array, there is not another array they can interfere with. So much less interferences in the venue. This array only interferes with its own reflections, but I have much less areas with a high amount of pressure in low frequencies and areas with hardly anything on pressure concerning the low frequencies. A little bit different when I go to crossover or to productions, film music. Mostly all of the time I prefer a flown situation because I don't have these distortions. I call it distortions in level. It is not a distortion the way that it really gets the distorted way as it is with a distorted guitar sound. No, a distortion is a misbalance in level. And as soon as I have the subs stacked, I will have this problem. Of course, sometimes for very high sound pressure levels and when you need to feel that, then it's a good decision to place them on the ground. But you have these distortions. Sometimes there's a need of placing the sub-speakers on the ground. And more or less there are four kinds of placing the subs. It is just a single stack, no processing. You can do an end-fired system, you can do a cardioid system, or you can do a bass line. So what are the preferred things? I think everybody can have his own tastes there. But for me, I have to say I really like the end-fired system. And why do I like it? With the end-fired system, you have equal level on all frequencies towards the audience. On the backside of the end-fired system, there sum up somehow, some cancellations, some summations, whatever. On a cardioid system, it's totally vice versa. I have a perfect cancellation on the backside, but they sum up somehow in the front. For example, if you make a cardioid system at a distance of 1 meter from speaker to speaker, so you have a time delay of 2.9 milliseconds, so you delay the rear speaker 2.9 milliseconds and you reverse the polarity. You have on the front of the speaker system, you have 60 dB less at 40 Hertz than at 80 Hertz. More or less, I don't want to accept that loss, which you just can repair by putting some filter on it. So you just give away a lot of energy. And for the ear, it's not 6 dB. For the ear, it's more than 6 dB. Look at the Fletcher-Munson curve, and for a lower sound pressure, to have the same feeling of recognizing it, you need even more energy. So depending on the level where you are, it's 6 dB plus something. You have less on the 40 Hertz than on the 80 Hertz. And there an end-fired system behaves much better. It's just equal on all frequencies in front of the speakers. And that's what I would like to achieve. Yeah, thank you.